I just wrote everything out so everyone understands. So, you know what? Actually, I guess it's all right. Okay. I mean, what I could do is, I'm not going to do it now, but maybe I could do, well, we'll see more examples of factor by grouping in the next part, because there's one more factoring technique I want to go through, and that actually involves factor by grouping. So we'll see more examples of this. But what I could do is, like in that kind of example, I could skip this step here. I don't know if you can see it or not, and that might help. So. But here again, yeah, this is the final answer down here. Yeah, I hope that makes sense. All right. Okay, any other questions? I'm not trying to dismiss anyone's questions. I really want everyone to, I do want everyone to be able to do this. All right. I mean, there is an example I want everyone to try here, this example. So let me do something real quickly before I get to that. Because I know someone else did ask another question. I think it came up in my other class also. I hope this helps. Okay. Let me just quickly modify these notes. That better? Is that better for everyone, or?
Yeah.
It's a little bit easier to see what's happening?
Uh-huh.
Okay. You know what? I can go that way. I'll do that from now on, okay? I mean, I was trying to show all the steps, but I guess, you know, sometimes that helps, sometimes it doesn't. So, but I'm hoping this is easier for everyone. So, okay. I mean, yeah, I mean, visually, you can probably see that when you pull the 3x squared plus 1 out, what's left over is you have the 4x cubed, and you're pulling the whole thing out. So you have to put a 1 there to, as a, I don't want to say placeholder, but as something. So I guess in a sense it is a placeholder. So, okay, so the next problem, wait, let me get to it. Oh, geez, there we go. So for the next one, I want everyone to try out as well, because I want everyone to practice this. Okay, so let me just pause the clock. It'll take about, you know, like 10 minutes, 5 or 10, between 5 and 5. All right, so let's go through this one together. All right. So again, this one, of course, you're going to have to complete by factor by grouping. Okay. All right. Okay, so for this, okay, so for this one again, it's always good to get the GCF factored out first. Okay, and that's what we're going to do. All right, so notice there's a non-zero constant term. Okay, a non-zero constant term. So there's a term with no x in it. So in the GCF, our m is 0. Okay, the smallest exponent of x, that is. All right, but now what about the coefficients and the constant term? Well, if we were to list all the factors of each one, so for 9, we have 1, 3, and 9. For 4, we have 1, 2, and 4. For 36, we have 1, 2, 3, 4, 6, 9, 12, and 18. For 16, we have 1, 2, 4, 8, and 16. And again, looking at the list, you can see that the only common factor among these four, among the coefficients in the constant term, is a 1. So 1 would be our B, the greatest common factor among the coefficients. Hence, the GCF is just 1 times x to the 0, which is 1. If you can't see the slides, again, please say something. So, Okay, so that's our GCF. So the next step is we have to form our two groups now, right? The first two terms, we get a group. From the second two terms, we get a group as well. And we, the groups we indicate by using parentheses. So from the first group here, right, the 9x cubed plus 36x squared, okay, so we want to find, again, we have to find the GCF of each individual group. So we're finding the GCF of this thing, okay? So the smallest exponent of x, as we can see, is 2. So our m would be 2. 9 itself is a factor, okay, of 36. 9 is a factor of 36. So 9 is the greatest common factor among the coefficients. I mean, even if you went back here and just looked at the 9 and 36 and forget the other two rows, the other two numbers that is, you would see 9 is the biggest common factor of 9 and 36. So for this one, the GCF, B would be 9. The GCF would be 9 times x squared. Okay? 9 times x squared. Good. And now we factor it out. We have 9x squared times 9x cubed plus 36x squared. Again, we have to divide by 9x squared, okay? That's what we have to do. We have to divide by 9x squared, okay? And so by doing that, we have to divide into each term in the sum, as you can see, okay? We divide into each term in the sum, okay? And when you do that, the 9's cancel. X cubed over x squared, that's gone. That becomes x, right? You subtract the exponents. Here, 36x squared over 9x squared. Well, 36 over 9 becomes a 4. The x squares themselves cancel. So this is what we get. Now that's for the first group. So we're going to substitute that. That's what we did. For the second group, we do the same thing. For 4x plus 16, right? Well, there's a non-zero constant term. So the smallest exponent of x is 0, or power of x is 0. For 4 and 16, if you went back and looked at, let me see if I can go to it here. For 4 and 16, you would see that the greatest common factor of 4 and 16 alone is 4. Mostly because 4 is a factor of 16. So it follows that 4 is the greatest common factor among 4 and 16. So the GCF here is just 4. So we factor that out. And when you factor it out, you have to divide, as you can see. Okay? So we have 4 times 4x plus 16 over 4. But again, you divide into each term. 4x over 4 is x. 16 over 4 is 4. Okay? So we have that. Let's substitute that in. Now, I mean, there's more work here, but by the way, but once we substitute, we get the second line here. But you can see we have something in common in parentheses, right? X plus 4. So once you take it out in front, what you're going to be left with is, I mean, this is the work that you actually have to do to get to the last step. That's the work that happens. But again, you can really just skip to the last step. And hopefully you can see that when you remove the x plus 4, you put it in front, 9x squared is left over in the first term, and 4 is left over. I mean, this is extra work. I was showing all the steps, but the impression I'm getting is that's causing more confusion. So from now on, I'm not going to show all the work. Or maybe what I'll do is I'll show all the work, but then like on another slide, I'll show going from here directly to here. But I hope everyone understands. I mean, if you did do all the steps, you put x plus 4 in front, then you have to divide, right, by it. And as before, you divide into each term, you have cancellation, and that's why you get 9x squared plus 4. Why algebraically? So, do you have any questions about this?
In the beginning, like when you factor like literally the beginning, I put x was the factor, so that's where I messed up. But I thought like,
You mean that this thing?
yeah, I thought you could put x for some reason, but I can't put x because 16 doesn't have an x, right?
Exactly, yeah.
Okay, so if it was like 9x to the third plus 36x squared plus 4x plus like 16x, then I could do the x.
Then you could do that, yeah. But because the x has to be in each term at least.
When I did do the x, I literally got the same answer, just not 9x squared in the end. I just got 9x.
Oh, sorry. All right. At least now you know, so, okay. And everyone too, so. Are there any other questions on this? Yeah, I really want everyone to understand, so.
Does it matter if we put 9x squared plus 4 or x plus 4 first? Does it matter?
It doesn't matter.
Okay.
I mean, because multiplication is commutative, meaning you can multiply in any order. So, I mean, there might be, how do I say this? I mean, maybe a mathematician might say, well, the x plus 4 has to stay first. But if you interchange the order of these, I'm not going to take off points for it. I mean, this stuff I think is hard enough as it is. So, so. Any other questions? Oh, there we go. Okay, so let me share the worksheet so that everyone has, so now you guys, everyone can work on it for a bit. I mean, there were 4 questions on it. So, but for time consideration, I don't think we'll get to all 4. So maybe like work on just the first 2. Let me share it. So. Here it comes. Here we go. Hope everyone can see that. Just do the first 2, but I will post solutions to all 4 of these as well. Okay, so I'm going to stop the recording.